Studies have highlighted the northwest of the country, and in particular around Delhi, is experiencing some of the highest groundwater depletion rates globally. So the population of Delhi has now exceeded 33 million, and it's projected to continue growing to become one of the most populous cities in the world by around 2028. So this not only puts pressure on water resources, but also pressure on land use, which has resulted in unchecked urbanisation, which in turn kind of interacts with the groundwater dynamics. Then on top of that, we have climate change intensifying the issue. So climate change in the form of increased temperature, increased evapotranspiration, but also more unpredictable and extreme precipitation patterns. So there's quite a number of sort of increasing pressures on the groundwater dynamics in the area. So it's becoming increasingly important to be able to accurately quantify and understand how the groundwater levels are changing. So the greatest kind of barrier to sustainable groundwater management is being able to quantify accurately how groundwater levels are changing. Traditionally, this would be done by measuring the water table at wells. However, not only is this expensive to drill and maintain groundwater wells, but this method is limited due to a sparse spatial distribution, wells that aren't regularly maintained, but also restricted data access, particularly across political boundaries, which many of the large aquifers will span. When GRACE was launched, or GRACE is the Gravity Recovery and Climate Experiment, it was launched in 2002, a joint satellite mission with NASA and the German Space Agency. And it provided the first satellite mission that provided the ability to globally map groundwater levels at large scales. So the idea behind GRACE is that it measures gravity anomalies globally every month, which can be kind of translated into show you how terrestrial water storage is moving around the planet. And when you remove these surface water components, which are generally a lot better modelled, you're left with the groundwater storage. Then more recently, people have started to look at SAR data to understand how water levels are changing under the surface. So SAR data and INSAR techniques can quantify land subsidence, which provides an indirect observation of groundwater storage change. Not only is this cost effective with the availability of Sentinel-1 data, for example, but it's got small spatial resolution and a large spatial coverage. However, it is quite difficult to translate it directly to a groundwater storage estimate, but it does provide us with an understanding of what is going on beneath the surface. So with that, those sort of three data sets in mind, the aim of my overall kind of PhD project is to investigate the capabilities of these different data sets and how they can improve our understanding of changing groundwater resources in Delhi. This is a different presentation, sorry. Yeah, so this kind of, this workflow shows the overall sort of methods I'm using in my PhD. I don't think I'll have time to go over all of it today, but I'll just give a brief overview. So the borehole data we collected first, this was available online at the CGWB water, their online water portal. Combining this with geology data, specifically data on the specific yield, we translated the groundwater level measurements into groundwater storage, so it was comparable to that from GRACE. GRACE was combined with the GLDAS model outputs for surface water to isolate groundwater storage. And then the first sort of objective was to compare these two data sets, both over space and over time. And then we spent a little bit of time also looking at the drivers of groundwater storage change, combining data on anthropogenic and climate influences with a kind of simple approach, just using multiple linear regression to see what are the main drivers of groundwater storage change and how that varies spatially. Then with the INSAR data, we used Sentinel-1 data, and we downloaded data over the period 2015 to 2023. And this was processed using the intermittent small baseline INSAR processing approach. This is kind of a novel method developed by Andrew Souder, who works for a company called TerraMotion in the UK. And it kind of processes a pixel in a SAR stack, which is only intermittently coherent, as well as those that are coherent throughout the whole period. So it results in a better coverage, particularly over natural settings where INSAR methods aren't usually, they don't usually perform too well. So I compared the INSAR kind of time series of those of groundwater and sort of looked at that relationship. And what I'm currently working on is trying to translate that land subsidence into a groundwater storage estimate. So the two maps here, the first one shows the GRACE groundwater storage anomalies. It's a linear trend between 2005 and 2016, and the map on the other side shows the same thing, but what we're seeing in wells across the basin. And this is actually the Upper Yamuna Basin because of the scale of GRACE. This study we've done it on a larger, just a larger spatial scale to get a bit of, so you can see the variation in GRACE. So you can see like the general pattern kind of matches up. So the north of the basin is depleting, whereas in the south there is a bit of recharge. However, you're not getting the sort of spatial intricacies that you can see, like for example in that inset just of Delhi there. In general, they also match quite well temporally. This is just a basin-wide time series. So wells is shown in red, and the different GRACE solutions is the other colours. And we used these different lines of from GRACE solutions from different processing centres, and we found that the JPL mask-on approach, which is generally considered a more rigorous approach, performed best. This is what was meant to be at the end, so I'm just going to skip over that. So this here is now moving on to the INSAR results. So this is also for a different period. This is between 2015 and 2023. So in the maps before, the dominating trend was kind of decreasing groundwater storage, whereas in more recent years there's been a bit of recovery. So you can kind of see the spatial pattern in the INSAR, so that's land subsidence against the trends you're seeing in wells, and it matches up. Just from looking at it, it looks like it kind of agrees quite well. So we can see some areas with high subsidence that also have decreasing groundwater storage in wells, and also areas in blue there that have a bit of uplift. That area is also dominated with wells with increasing groundwater level. However, although it kind of, the big picture looks all right, it is a bit of a patchwork of agreement, in that there's some wells that they don't really seem to match at all. So in this map now, you can see the Pearson's correlation coefficient between the time series of groundwater level against the time series or the INSAR time series within a 500-metre buffer of each well. And in general, there's a lot of green, so that's good agreement. There's some wells, particularly in the south, that have almost perfect correlation between INSAR and groundwater level. But then there is also locations that's moderate correlation, and even a couple there that are showing like completely the opposite trends. This is just an example of one well where we're seeing good agreement. The units here are also different, so it's groundwater level change since the start of the time period, and INSAR displacement since the start. But while the time series doesn't match up, it's still, the trends look quite similar. Again here, the time series is very closely related. I think the correlation here was maybe 0.96. But then just beside, so that well was there, really good agreement, but over here, the time series are just showing completely different things. And this is kind of opening up the question of what is causing this relationship and this kind of patchwork of relationship that we're seeing across Delhi, which is leading me into what I'm working at the minute. I only sort of got initial results for this, but I'll just quickly talk you through what I'm trying to do. So I've got our groundwater data, the INSAR data, and a bunch of data on different covariates, so things like climate, physiography, so like land use and land cover, distance from streams and roads, topography, geology, and some soil characteristics. I'm currently trying a few different methods, including machine learning, geostatistical methods like spatiotemporal kriging, and then also a physical model. which is kind of based on the mathematical equations that govern the relationship between like water injection and subsidence. And I'm using these methods to try, and the overall aim is basically to create a high resolution groundwater storage map based on the IGARSS and these covariates, but also through this understand which of variables are most important in influencing the relationship between the groundwater and subsidence. And then that's me. So thank you very much for
Thank you, Rebecca. We do have time for questions. Anyone, please? The microphone's there.
Thank you very much for your very interesting presentation. I would like to ask, you use 3 different data sources, right? And with the different spatial resolution, how you can handle it? Because it's very important for mapping something like that. So thank you very much.
Yeah, thank you. So with GRACE, we didn't try and summarize the well data. We just looked at it like as it is here. So just comparing visually what we're seeing. Whenever we look basin-wide, I think we use spatial or creeping to sort of average the GRACE time series monthly. The well data is actually only available 4 times a year in India. When we look at IGARSS, again, we haven't summarized wells here yet. It's just sort of comparing visually what you're seeing in the wells, exactly what they are, and the IGARSS. And here, whenever we're comparing the time series, I've looked at different sort of buffer zones around the well. So this one is showing a 500-meter buffer around the well, taking the mean IGARSS value. But we've tried different, like maximum, minimum, and different quantiles to see what the relationship is with that. So just to answer your question, I'm not sure if I just went and rambled about it. That's it.
Okay, thank you. I think we have to move on. Okay, so our